today we're going to go over a different way to do multiplication. Now, most of the students are very comfortable with the standard algorithm for multiplication, but today I wanted to introduce something a little different that's going to help see things kind of in a different way and just have an opportunity for students to be able to multiply in a multitude of ways and not just the one. So this is called aerial mathematics or aerial multiplication, and the great thing about this is for visual learners it really breaks down multiplication and you can really see it step by step, and it also works on multitudes of things. So not only are you working with multiplication, but you're working with multiplication with numbers 1 through 10, as well as being comfortable starting to learn area, which is great to introduce to students. So I'm going to go ahead and start off with a problem and demonstrate how we set it up and how it looks, and then we'll go through why it works. The first problem we're going to do is 521 multiplied by or times 24. So this is a very large problem, and for a lot of students this is insanely daunting to look at, especially that 521. They look at it and even knowing the standard algorithm start freaking out because of how large it is. So all we're going to do now is break this number down, and it's very, very simple. So how many hundreds do we have? 5. But we're going to make sure to put the zeros behind it too. How many tens do we have? 2. But we make sure to put the 0 behind it. And how many ones do we have? 1. And then over here, how many tens do we have? 2. Make sure to put the 0. And how many ones? 4. Next, all you have to do is make a box. And then divide out the sections by the numbers. So we'll get 500 a section, 20 a section, and then 1 has a section, and then 20 a section going this way, and then 4 has a section. Now all we're going to do is focus on each box one at a time, and this helps that breakdown point. Now still 500 looks very large, however now we have zeros behind it, and this makes the problem 100% easier. So now all we have to do is say, what is 5 times 2? 10. How many zeros are in our problem? 1, 2, 3. Add 3 zeros. 10,000. What is 2 times 2? 4. How many zeros do we have? 2. Add that behind the 4. And while students should know that any number multiplied by 1 is going to be that number, so 20 times 1 would be 20, we could still do it the same way. What is 2 times 1? 2. How many zeros are there? 1. 20. Now we're going to do the same thing for the 4. What is 4 times 5? 20. Add 2 zeros for 2,000. 4 times 2 is 8. Add 1 0, 80, and 4 times 1 is 4. Now, there's different ways we can go about this next part. Students can either add them going down in each column, or they can go across and then add down. I'll do both ways in different problems, but we'll start off by going down. So 10,000 plus 2,000 is 12,000. 400 plus 80 is 480. And 20 plus 4 is 24. Now I'm going to set it up going down. What's 12,000 plus 480? $12,480 plus our 24. 4, 10, carry the 1, 5. We get 12,504 as our final answer. And like I said, this is so fantastic because kids are able to see it broken down. When we're multiplying the standard arithmetic, all kids see are numbers going down and they're multiplying them, and sometimes it gets confusing on what place value to put it in, but here there's no guessing. They know that this is 500. They know that this is 20. And you can easily see how many zeros are supposed to go behind that number. And they're still doing everything the same way. The 2 is getting multiplied, or the 20 I should say, is getting multiplied by every single number in the 521, and the 4 is getting multiplied by every single number in 521, and that's what leads us to this number right here. While this may take a little bit longer for students who are kind of doubting themselves, this is a fantastic way for them to see their work written out and kind of do that double check. So while it may be a little bit more time consuming, getting that actual understanding of what this looks like and why it works is a lot easier for students, and it gives them a lot more room to work with writing wise as well. So I'm going to do 2 more problems just to show you that it can work with not only large numbers but small numbers as well. So say we wanted to do a problem simple as 35 times 22. We're just going to do the same breakdown, and it's going to be incredibly easy for them to set up. So how many 10s do we have? 3, but since they're 10, it's really 30. We add that 0. How many 1s? 5. Again, for 22, how many 10s do we have? 2. But since it's 10s, it's 20. And how many 1s? We have 2. We make our box and make sure every number has a square, so we'll just divide that in half and divide this in half. Now again, they don't need to know what 30 times 20 is. All they have to know is 2 times 3. And then they just add the zeros that are in those numbers. It's so simple for them. So what is 2 times 3? 6. How many zeros? 1, 2, add it behind the 6. What is 2 times 5? 10. How many zeros? 1. 2 times 3? 6. How many zeros? 1. 2 times 5 is 10. Now this time I'm going to go across and add. So it's 600 plus 100, 700. And what's 60 plus 10? 70. Now we can go ahead and add down. And our answer is 770. Again, it's very simple, very easy. It breaks it down, and visually it's a lot easier to understand the concept of multiplication. So we're going to do one last problem. I'll switch to a different color on this one. And this is pretty much as basic as it gets now without having the numbers below 10. So we'll just do a simple problem like 19 times 2. Set it up the exact same way. How many 10s do we have? 1, but it's actually 10 because it's in the tens. How many 1s? 9. How many 1s? 2. Make a box, split it in half. What is 2 times 1? 2, add 1 0. 2 times 9 is 18. 20 plus 18 is 38. So, as I said before, it's just a great way to break it down. They're working on their values and understanding where the numbers go, and it's a lot simpler when you're breaking down these numbers and then you're working with things like addition, which is familiar and comfortable. So this is a great technique for students that need that visual. It's a great technique for students who want to check their work, and it's a great technique to teach your students and your child to understand why multiplication happens the way it does and what it looks like. Thank you.